And it says, what's the total resistance? So you got to remember, we said the total resistance is simply adding up all the other resistors here. So we're going to add number 1 and number 2 together. And so I'm going to take the 5 plus the 35 ohm resistors, and you end up getting 40 ohms total. So 5 from, let's see what else, 5 from here, sorry. It was 35 and 5. So I got the 5 from here, and I got the 35 right here, and you add those two together. Then number 2, it says, what's the total, what's the reading on the ammeter? Well, an ammeter measures current, so since current is voltage divided by resistance, I'm just going to take the 120 volts that the circuit has in it, divide it by the 40 ohms of resistance, and that gives you a total of 3 amps. Then asking the next question, will the fuse blow out, or will the fuse melt? Absolutely not, because the fuse down here, if you look at it, is a 10 amp fuse, but only 3 amps go through the circuit. So it's not going to melt whatsoever. Let's go down to number 4 real quick. It says in the circuit in diagram B, what's the total resistance? Well, they added another resistor, another 5 ohm resistor there. So I'm going to do the same thing I did up here, just bring it down. And so I got the total resistance now is 5 plus 35 plus 5 again. So you get a total of 45 ohms of resistance. This says, well, what's the circuit on the, what's the reading on the ammeter now? Do the same thing we did here. I equals V over divided by R. So we take that 120, divide it by 45 ohms of resistance, and now I'm down to 2.6 amps. So I added another resistor, and resistance went up, so the current goes down. Every time you put a kink in a garden hose, you got less water coming out. So if you put another resistor on a series circuit, you get less electricity. Will the fuse melt? Absolutely not. Once again, because you only have 2.6 amps going through it, and it's a 10 amp service. Now you get a little bit trickier, because on number 7 it says, what's the resistance in the parallel portion of part C? Well, if you look at this, you have a parallel portion and you have a series portion. So let's take the parallel portion first. Remember, the formula for parallel is 1 over the total resistance equals 1 over the first resistor plus 1 over the second resistor. So I'm going to take 1 over 35 plus 1 over 5. Well, we got to find a common denominator, so 35 is going to be my common denominator. So it's going to be 7 over 35 for the 1/5 becomes 7 over 35. That gives you 8 over 35, but that's not the total resistance. That's 1 over the total resistance. So let's flip-flop that to make it 35 over 8, or 4.37. Oh my gosh, that was terrible. 4.37 ohms. Well, then ask, what's the total resistance? The total resistance, you now have to add the next resistor to it. So if this is 4.37, the 4.375 actually ohms, okay, I'm now going to add this one up here, which is another 5 ohms to it. So if we add 5 to this right here, my total resistance is going to be 9.375. 9.375 ohms. So now let's know what's going to be the reading on the ammeter if you have that. Well, once again, I equals V divided by R. So I'm going to take that 120 and divide it by the 9.375. And that gives me a total of 12.8 amps. The next question says, will the fuse melt now? Absolutely, because 12 is greater than the 10 amp fuse. So if you look at this 10 amps over here, you only have a 10 amp fuse, and you got 12 trying to go through there, you're going to blow up the wires. So how can I rearrange these things without so it doesn't blow the fuse? Well, what I'm going to do here is, shoot, I just rearranged the wrong one here. I'm going to take these this 35 and put it up here, and make these two 5 amps. So by putting that big 35 there in series, it makes the resistance go way up. And so you have less current going through. So I switched the 35 and the 5, and that will give you a lot less current. Okay, so that is video number 40. We're going to stop it here, and now go on to video 41 next. Bye.